You know that feeling, right? You ask an AI a question, and it gives you back an answer that is so confident, so detailed, and just completely wrong. We've all been there. It's what people call hallucinating, and honestly, it's one of the biggest headaches with AI today. But what if there was a way to stop it? What if we could give that AI a library card and maybe a fact checker to go with it? Well, that's exactly what we're diving into. So, here's our game plan for this explainer. First, we'll look at why AI makes stuff up in the first place. Then, we'll introduce the really clever solution, giving it a library. After that, we're going to peek under the hood of what's called the RAG machine, compare the simple and the more advanced versions, see how it's actually built in the real world, and then wrap up with why this is such a big deal for the future of AI. All right, so why does this even happen? Well, at its core, an AI can only give you answers based on the information it was trained on. It's kind of like asking a brilliant historian from the 1700s to explain how the internet works. They could probably give you a very eloquent, well-structured answer based on everything they know, but it would be totally wrong because the internet is completely outside their world, their training data. And here's the kicker. The AI doesn't know what it doesn't know. Let's make this real with a perfect example from the source material that just shows this problem so clearly. Just imagine for a second, you're new to AI, you're trying to learn, and you kind of remember a term you overheard somewhere. So you go and you type in a query like this one, define a RAG store. Now, in your head, you've heard the term RAG alongside techie stuff like LLMs and vector stores, but you've gotten the words a little mixed up. You're asking a legit question, expecting a technical answer. And this is what you get back. Now, look, the AI isn't being stupid here. It's being logical. It sees the word rag, a piece of cloth, and store, a place that sells things, and puts them together. It's a perfectly logical answer, and 100% wrong for what you were actually asking. It's a complete misunderstanding, and it highlights a massive problem. And this, right here, is where RAG comes in to save the day. See, the solution isn't just to throw more and more training data at the AI, it's to give it access to external, current information in real time. It's all about giving the AI its very own library that it can check before it opens its mouth. Okay, I love this slide because it has the perfect analogy. Think of an AI like a really smart student. This student knows how to read, how to write, how to structure an argument. But if you ask them to write an essay on a topic they've never, ever studied, they're going to have to make stuff up. RAG is like sending that student to the library. Step 1, they get the essay question. Step 2, they go search the stacks for the right books and articles. That's the retrieval part. And step 3, they use that specific info they just found to write a great, accurate essay. That's the generation part. So with that analogy in mind, here's the more official textbook definition. Retrieval Augmented Generation, or RAG for short, is a framework that does exactly that. It fills in the AI's knowledge gaps by fetching relevant data from outside sources on the fly, and then uses that fresh data to create a much better, more accurate answer. So how does this whole RAG machine actually work? Well, it's not just one single thing. It's more like an ecosystem with 4 key players, and each one has a really specific job. Let's break them down. First up, you've got the retriever, and you can just think of this as the librarian. Its whole job is to manage the knowledge base. It grabs data from all over, PDFs, websites, databases, you name it, and then it processes and organizes all of it so it can be searched incredibly fast. Next, we have the generator, or the writer. This is the part of the system that takes your original question, smashes it together with the documents that the librarian just found, and then creates a brand new, super detailed prompt. It then hands that prompt off to the AI to write the final, informed answer. Then there's the evaluator, who I like to call the fact checker, and this part is absolutely critical. It looks at the answer that was just generated and scores it for quality. It uses some math, like something called cosine similarity, which is really just a fancy way of measuring how related 2 chunks of text are, but it also relies on actual human feedback to make sure the answers are accurate and relevant. And finally, we have the trainer, or the teacher. This component is responsible for the big foundational AI model itself, the one that was trained on a huge chunk of the internet. The trainer is also the one that handles fine-tuning that model, kind of like sending it to a specialist class when it needs to learn about a new specific topic. Okay, so now that we know the key players, it's really important to get that not all RAG systems are built the same. It's actually a spectrum running from pretty simple to incredibly advanced. And we also need to be super clear on how it's different from another technique you hear about all the time, fine-tuning. So on one end of the spectrum, you've got what's sometimes called naive RAG. It's the basic version, often just using simple keyword searches. But on the other end, you have advanced RAG. This is the heavy-duty stuff, using sophisticated techniques like vector search, which is a way of searching for meaning and concepts, not just matching words, to sift through massive, complicated sets of data, even things like images and audio. Now, what about RAG versus fine-tuning? This slide nails the difference perfectly. RAG is like giving the AI an open book test. All the knowledge is sitting right there in an external library that it can look at anytime. Fine-tuning, on the other hand, is like sending the AI back to school. You teach it a new subject, and that knowledge gets absorbed, baked right into the model's brain. The original books are gone, but the memory of what it learned remains. So we've got the theory down, but how do people actually build one of these systems for a real company or product? Well, in the real world, it's set up just like a factory production line, breaking the whole big process down into smaller, much more manageable steps. And this pipeline approach is just super practical. You can have one team that does nothing but find and clean up the data. A second, more technical team handles turning that data into vectors and storing it. And a third team builds the actual app that users will talk to. This means everyone can work at the same time, but it also makes fixing problems so much easier. If the AI is giving bad answers, you know exactly where to look. Is it the data, the storage, or the final generation step? Okay, we have been deep in the technical weeds of the what and the how, so let's zoom out for a second and talk about the why. Why is RAG such a massive deal for the future of AI? Well, it comes down to a few huge benefits that directly fix some of the biggest weaknesses in AI models today. First, and this is the big one, it drastically cuts down on those hallucinations. But just as important, it creates a trail of breadcrumbs. Every answer can be traced back to the exact source document it came from, so you can actually fact-check it. It also builds in a natural way to get human feedback and lets developers have way more control over what the AI is allowed to talk about. And that really leaves us with this final question to think about. As these AI systems get woven deeper and deeper into our jobs, our research, even our day-to-day decisions, being able to trust what they say isn't just a nice-to-have feature. It's everything. The real challenge for all of us is figuring out how we make sure that trust is not just given, but is truly earned.